Assalamualaikum and hi everyone. So today we're going to present about our group project, MIPS Assembly Program. This project will converting numbers to binary, octal, and hexadecimal. Project overview. This program is designed to accept 10 user inputs, each between 0 and 255, and convert them into their respective binary, octal, and hexadecimal representations. The key features of this program include input validation, where the program ensures that the enter values are within the valid range. Data section. In the data section, the program defines several important variables. Prompt holds the string to prompt the user for input. Newline is a new line character used for formatting, and message binary, message octal, and message hexadecimal store the headers for binary, octal, and hexadecimal outputs. The invalid message variable stores the error message displayed when invalid input is entered, and the numbers array store the 10 valid user inputs. The octal temporary array is used to temporarily store octal digits during conversion. So we have four things that we're going to present today. First is text section, which is initialization. Second is input loop. Third, conversion. And fourth, program termination. So first one is text section initialization. So how we want to initialize our code? So as you guys can see here, we start with main and initialize loop counter to store the array. So in the text section, the program begins by initializing the register. T0 is used. String T0 is used as a loop counter, and string T1 is set to 10, which represent the number of inputs the program expects to receive from the user. This initialization prepares the program for the user input collection and the subsequent conversion processes. So next one, I will pass it to my group member.
For the input loop, next. So this is the sample code to print from message LISV04, LASA0 prompt is called. The program prompts the user to enter a number by displaying the message stored in the prompt using syscall instruction. And then for the read user input, LISV05 syscall move from SV0 to ST2. It reads the user's input using syscall. You can see there which stores the input in a register for further processing. This is the sample code to check if the input is in the range, which is from 0 until 255 using BLT and BGT instruction. If the number is outside the valid range, the program displays the invalid message and asks the user to enter a valid number. When valid input is received, it is stored in the number array for later conversion. So this is the part for the conversion. First thing first, to print in binary conversion, you can see the coding there. So after collecting all the 10 inputs, your program displays the header message binary to indicate the start of the binary conversion process. For each number, the program uses bitwise operations to extract and display each bit one by one. Especially, the SRL operation shifts the bits, and the NI operation isolates each individual bit. Each extracted bit is printed using a syscall for character output, which constructs the binary representation. Next. And then we move to octal conversion. Once the binary output is displayed, the program moves on to octal conversion by first displaying the header message octal. So to convert each number to octal, the program uses bitwise operation to group the bits into 3-bit set, which represent each octal digit. And then the extracted octal digit are stored in the octal temporary array in reserved order, and the program then prints them in the correct order by traversing the array backward. Last but not least is the hexadecimal conversion. After completing the octal conversion, the program displays the header message hexadecimal to indicate the start of hexadecimal conversion. For each number, the program uses the MIPSYS call, which is LISV034, to directly print the hexadecimal equivalent of the number. This syscall simplifies the conversion process and output the hexadecimal representation directly.
Next, the program termination. So after processing and displaying all 10 numbers in binary, octal, and hexadecimal format, the program gratefully exits using the syscall instruction with LI register V010, which terminates the program. Next. So this is the demonstration. The program is valid. You can see that it runs the program. We enter 10 numbers in between 0 and 255. Then the program will run the output and convert the input numbers to binary equivalents, octal equivalents, and hexadecimal equivalents. Next, this is the demonstration of the invalid program. So when we enter the number out of the range, so the program will invalid. It will ask us to enter the correct numbers that is in between the number 0 and 255. Next. So the key concept recap. To recap, the program performs input validation using conditional branches like BLT and BGT to ensure the inputs are within the valid range of 0 to 255. Then for the conversions, it employs bitwise operations for binary and octal conversion, including SRL for shifting bits and ND for masking individual bits, while hexadecimal conversion is done using mixed syscalls. Next. To conclude, this program demonstrates several important concepts such as input validation and converting numbers into binary, octal, and hexadecimal formats. It meets specific features like syscall for output and input handling and bitwise operations for conversions. The key learning outcomes include understanding how to manage user input, perform bitwise operations in assembly, and leverage mixed instructions for various conversions. That's all from us. Thank you.